This is section 5.1, and we're going to talk about operations on functions and combining functions. So if we look here, the first part is on operations. So we're used to seeing an f of x, a g of x, but now we might see f plus g of x. That just means we add the two separate functions. If it's subtraction, we subtract them. Multiplication, we do that. Division, we do that. The only disclaimer here is that that denominator cannot be 0, so sometimes that affects the domain. The composition of functions is a different thing. So now we're going to see either this notation, f of g of x, that's not multiplication, is a composition, or we'll see it like this with this little circle in it, f of g, g of f. And what I usually have students do is go ahead and draw that arrow. This is telling you you're going to put g of x into f. You're going to put f of x into g. It's always the one on the far right goes in the left. You're putting one function into another. Let's look at this example. You're given f of x is 3x plus 5, and g of x is x squared minus 8. So if we're doing f of g, that means we want to take g and put it into f. So up here, the purple line is saying take this yellow thing, go all the way over here, and put it for x. So we have 3 parentheses, this yellow function. We go ahead and distribute the 3, and we clean it up, and we get 3x squared minus 19. For g of f, we're going to put f into g. So that is this red line taking that blue function, putting it in this x, and that x is squared. So we'll put our blue thing here and we'll square it. So we have that squared minus 8. That becomes 9x squared plus 30x plus 25 minus 8. Combine these two and you get plus 17. So those are the two main concepts we're going to go for. Let's go ahead and look at our problems. Number 1, you're given an f of x and a g of x. What is fg? That means we're multiplying them. It's not a composition. So we'll just multiply these two together and get 8x to the 4th. Number 2, you've got f of x, which is yellow, and g of x, which is blue. And we're asked to do all 4 operations of different numbers. So if we're doing f plus g of 4, you want to write out what's f of 4? Plug 4 in and you get 9. What's g of 4? Plug that into g and you get negative 14. Then you do the operation. 9 plus a negative 14 gives you negative 5. F minus g of 3. So you'll do f of negative 3, g of negative 3. Get those numbers and then you will subtract them. Watch your signs. You get a negative 12. Fg of 1. We'll do f of 1 and g of 1, and then we'll multiply those two numbers. F divided by g of 3. So we'll do f of 3, g of 3, and we get negative 5 over 7. So that's doing those operations. Now this one, we don't have numbers, but we are going to do our 4 operations with these 2 small functions. The first one says f plus g of x. That means we're going to add these two. Easy enough. It asks what's the domain. Well, that's a polynomial, all real numbers. There's no restrictions. F minus g, we're going to subtract. Again, no problems. We have all real numbers. F times g, we're going to multiply these two and get 30x cubed. Still all reals. Now this one, we have f divided by g, and it's 5 over 6x when you simplify. And the only number in the world that would be a problem, because this denominator can't be 0, is if x were 0. So here's our domain. All x is such that x is not equal to 0. Number 4, we've got 2 functions, a yellow and a blue. The difference is this one's subtracting it and this one's adding the square root function. So if we add these two together, the 4x and 4x, we get 8x. a negative one of these and a positive one, those cancel out. So we've got 8x. It wants to know the domain. Well, there's no problem with 8x. It's all real numbers. F minus g. Well, if you subtract 4x and you take away that 4x, you got 0. And then you've got minus this one, so you've got minus 2 of these. Now, for a square root function, the inside can be equal to 0 or can be positive. It cannot be negative. So you take this inside part and you say x minus 3 has to be greater than or equal to 0. Add the 3 over, so x has to be greater than or equal to 3. And that is A, and you'll fill in the 3. C part, fg of x. We're going to multiply these two together. And when we do, if you do 4x times 4x, you get 16x squared. Your middle terms will disappear because you got a minus and a plus. Square root of this times the square root of that, the square root goes away, and you just have x minus 3. So it's 16x squared minus x plus 3. Again, that's polynomial, all real numbers. F divided by g, we simply put one over the other. They don't ask you to clean that up anymore. And then the the domain of that is the same issue. Down here in that radical, x has to be greater than or equal to 3, just like this one up here. All right, let's look at 5. Number 5, now we're going to do the operations, but we're going to use the graph. And so we don't have an equation to plug into. We've got points to look at. So here is g of x, that's the line, and f of x is the parabola. So if we're going to do f plus g of 2, we want to find f of 2 and g of 2. All right, how do we do that? We go to the x-axis where 2 is, and then we go up till we hit the f function. That's at a y value of 4. So f of 2 is 4. G of 2, we'll go back to 2. We'll go till we hit the line. The y value there is 1. Then we'll add 4 plus 1 is 5. F minus g of 1. F of 1, we go back to 1 on the x-axis. We move up till we're on the f. That's at 1. F of 1 is 1. And then g of 1, you're at 2. So 1 minus 2 is a negative 1. F of g of 0. Well, 0's right here, so f of 0 is 0. G of 0 is 3. And you multiply those together, you get 0. F divided by g of 1. Well, we already know f of 1 and g of 1. We did those here. And that's 1 over 2. Then I think you could do the very same thing for number 6. It's just a repeat of that, different graphs, but you're still doing exactly what we did here. Number 7, we're going to use a table instead of a graph. So no longer do we have the picture of it, but we have the points already labeled here. And so in each box we have an x. So I've coded them yellow, and then this is f of x points, and here's g of x points. This is really much easier. So if we're doing f plus g of negative 3, f of negative 3, you go up here to your f box. This is negative 3, and f of that would be negative 4. G of negative 3, we go here, and that'd be a negative 1. You add those, you get negative 5. Do the same thing for f minus g of 1. F of 1 is 5. G of 1 is 2. 5 minus 2 is 3. GF of 2. So G of 2, we go up here. G of 2 is 0. F of 2 is 4. 0 times 4 is 0. Now, F divided by G of 2. We already did the F of 2 is 4, G of 2 is 0. But we're dividing 4 by 0. That is undefined, and that's a choice on each one of these. So there you go on that. So number 8 and number 9 are like number 7. So you should be able to do those. Let's look at number 10. Number 10, we've got g of x is this. Evaluate all of these things. That means plug them in. So g of negative 7, you just put negative 7 in here, you square it, you get 49, and you ultimately, over here, 4 times 49 minus 8, that's 196 minus 8, which is 188. Now, for g of b, you're still just plugging in b, but you get 4b squared minus 8. If you plug in x cubed squared is x to the 6th, so you get 4x to the 6th minus 8. That's what happened there. G of 4x minus 7. Well, that means we're going to take 4x minus 7, plug it in for x. So over here I've shown that. If you multiply 4x by 7, if you square it, you get this. Then you multiply 4 by all those numbers. Then you subtract 8, and you get 16x squared minus 224x plus 188. Number 11. You're given f of x and g of x. What is the value of f of g of 4? Remember, we're going to take g of 4 and put it into f. So you find g of 4, plug in 4 into g, you get 16. F, now whatever that is, you take that and do f of that number. We plug it in and we get 7. If we're doing g of f of negative 3, we start on the outside. F of negative 3, we do square root of negative 3 plus 33, so that's the square root of 30. Then we take the square root of 30 and we're going to put it into g, and if you square that, you just get 30. So do the thing on the outside first. Whatever you get, you put in the other function. Let's look at 12. All right, x cubed and g of x is x squared plus 6x minus 3. F of g, meaning we're going to take this and put it in here. And they're not going to make you multiply all that out. So you've just got x squared plus 6x minus 3 cubed. And the domain of that would be all real numbers. G of f, we're going to take this f and put it everywhere there's an x. So if we put x cubed right here, we get x to the 6th. If we put it here, we've got 6x cubed, and then we have the minus 3. Then and the domain is all real numbers. Now f of f, that means you're going to put x cubed in itself, and so you have x cubed to the 3rd. So you've got x cubed, you end up getting x to the 9th. You still have all real numbers. Number 12, and I need to get that where we can see that. Hold on just a second. Okay, so for 13, we've got f of x is 2 minus 7x. G of x is x cubed. If we want to do f of g, that means x cubed is going in for this x here. So we have 2 minus 7x cubed. That's all real numbers. For b, g of f, that means this f part, 2 minus 7x, is going in here. So 2 minus 7x cubed. If you come down here, I think I've shown the work. So if you do 2 minus 7x to 2 minus 7x, you end up with 4 minus 28x plus 49x squared. And you're going to multiply that by 2 minus 7x. And you could either do it what I did up here, whereas multiply 2 times all of this and then minus 7x times all of this. Or you can do it this way, which looks like an old-time multiplication problem. And you would do 2 times all of that, put it there, then do the minus 7x, and you line up the terms, and that seems to come out a little better, but here's the final answer. The domain is still all reals. And then f of f means you're going to put 2 minus 7x in for this x. So that's down here, 2 minus 7 times 2 minus 7x. Distribute the negative 7, and you end up with this as your final. Let's see what we got. 2 minus 14 is negative 12 plus 49x, and that's your final answer. Okay, I think that's probably the last one. There's a good bit to do there, but work on the compositions and the operations.